Hey everybody, this will be a quick video on inverse functions for college algebra because the way inverse functions are treated in college algebra is a little bit different from how inverse functions are treated when you get a little bit further into math. So for now though, we'll talk about inverse functions. So suppose that some function f is such that f of a equals b, meaning when you plug a into f, it outputs b. For some a that's in the domain of f. Then the inverse of f, which is written f to the negative 1, f inverse, if it exists, doesn't always exist, but if it exists, then f inverse is such that f inverse of b equals a. That is to say, f inverse takes b and outputs a. So notice that there's really just like a flipping of the coordinates that's kind of going on here. In particular, we know that under f hits the coordinate a comma b, which means that f inverse hits the coordinate b comma a. So in this way, inverses kind of undo each other. They're sort of like opposites in that sort of way. Just a couple of big notes before we look at some examples, because examples make this a lot clearer. First of all, again, this is true for college algebra. A function has an inverse if and only if it's one-to-one. So one-to-oneness, or as you get maybe a little bit further along in math, we call it injectivity. One-to-oneness is the requirement for a function to have an inverse. Why? Because one-to-one forces it so that the inverse takes, for any inputs of the inverse, it gives only one output. If a function is not one-to-one, like x squared for instance, then any input of its so-called inverse could or will provide two different outputs. So that's the big thing. First of all, if you're trying to find an inverse of a function, you have to check if the function itself is one-to-one. How do you do that? Well, probably the easiest way in college algebra is through the horizontal line test. So function has an inverse if and only if it is one-to-one. The second note that I'll make is just be careful with the notation. Careful, because f inverse, we write it with this -1 exponent, and with numbers, when numbers have the -1 exponent, it works as a reciprocal. It flips it. So, but that's not the case here. F to the -1 is not 1 over f of x. So let me just write that. F inverse of x is not, great big not equals, is not 1 over f of x. So this -1 notation, it sort of gets a little bit overloaded here. Because, like, remember, with numbers, if we have something like 2 to the -1, this is equal to 1/2. But it's not the case with functions. So don't get confused. F to the -1 is not the reciprocal of f. F to the -1 is the inverse. Inverse of f. Which, I mean, I guess it might be possible that there's some function whose inverse is its reciprocal. I'm almost positive that there is such a function. I don't know. Maybe not. Maybe that's just my kind of intuition talking there. But in any case, don't get bogged down in the notation is all I'm trying to say. Okay. So two things that you might be asked. One, you might be asked to find the inverse of a given function, and two, you might be asked to prove that that the function that you've found is the inverse of a function, or maybe you're given two functions and you're asked to prove that they're inverses. So let's do both of those things. Let's see here, what would be a decent example? Let's suppose that we're given the equation f of x equals x cubed plus 9. I don't know, just some numbers. F of x equals x cubed plus 9. So first of all, you want to verify, is this one-to-one? Yeah, it is. The cubic function is 1-to-1, and this plus 9, all that does is takes the cubic function, shifts it up 9 units, so it's not going to change the injectivity, it's not going to change the 1-to-1-ness of it. So yes, this is 1-to-1, so indeed, it definitely does have an inverse. How do we find that inverse? Well, to find an inverse, first of all, remember back when we were just little kiddos, we used to write functions this way: y equals x cubed plus 9. Remember that? Think way back. I'm kidding. That was probably like 4 weeks ago for you. So y equals x cubed plus 9. So rewrite it this way. And the reason that I recommend rewriting it this way is because, remember, when it comes to inverses, it's really just their coordinate pairs are being flip-flopped. So, if you were, by the way, if you were given like a graph of a function and asked to graph out its inverse, just take some coordinate pairs and flip the coordinates. And that'll be, I thought I saw something on the wall behind me. That was like a huge spider, sorry. Flip the coordinates, that'll be the inverse. That's how you graph it out. But it's the same idea down here. We can flip the coordinates. We can rewrite this so that we flip-flop x and y, and then solve it for y. And that will solve for you, that will find the inverse. So I will rewrite this first as x equals y cubed plus 9, and now I just solve this for y. Okay, well, what do I need to do to solve this for y? Well, I'll subtract 9 from both sides. So I would get x minus 9 equals y cubed. I'm going to write it this way: y cubed equals x minus 9. So just rewriting the reflexivity. Right, y cubed equals x minus 9. And then how do we solve this? Finish solving this for y. We take the cube root of both sides. So y equals the cube root of x minus 9. And this is f inverse. This is f inverse of x. So f inverse of x is the cube root of x minus 9. How do we verify that, though? Like, we don't just want to trust it. Maybe we want to kind of like check that that's the case. Here's another fact about inverses. If f and g are inverses, then their composite, f of g of x, equals x alone. And it's the same thing too. G of f of x also equals x. Technically, we should check that it's true that both f of g of x and g of f of x equals x. But again, in college algebra, it's likely you might get a teacher who throws some curveball at you, but it's likely that if f of g of x equals x, g of f of x will also equal x. So let's check. We're checking. Does f of f inverse of x equal x? That's what we're checking. Well, f of f inverse of x, f of x is x cubed plus 9. F inverse is the cube root of x minus 9. So f of f inverse is equal to f of x, so the cube, x cubed, but into x we're plugging the cube root of x minus 9. So the cube root of x minus 9 cubed plus 9. Here's my x cubed plus 9. All right, well, this cube root and the cube will cancel each other out, so that this just becomes x minus 9 plus 9. X minus 9 plus 9, the negative 9 and the positive 9 cancels. We just get x. So yeah, f of f inverse equals x, which means, yes, they're inverses of each other. Let's see, is there anything else that I should say quickly before we move on? Nope, I think that's about it. All right, let me know what questions you have.